Hello! In this episode of Finno-Greek machining, we are going to make air intake and output. Intake and output? Yeah, okay. The air holes for this rotating vane compressor cylinder. Well, there is nothing special about this, just drilling a bunch of holes. But attaching that piece on milling table is, well, that's one thing. And then the location of those holes, how they are oriented on different sides of the cylinder. Let's see. I will now give you a short introduction of my thought path with this one. So let's go and see about the location of the holes. Okay, here is now the cylinder and here is my Sharpie. Okay, this thing, well, it rotates this way. So this way, and when in use. And now it will output the air when the compressor is highest, when the gap between the rotor and the cylinder wall is smallest, and then it will be smallest at the compression when the gap is largest, as it is at that side. So if I would just simply place the holes directly to the highest compression area in the middle of it would mean that when that vane comes and blocks the holes, it already has lost some of the compression. That's not good. So we need to block the hole right when it's at the highest compression. So when it rotates a little bit, it will block. So the holes should be somewhere, the output holes I mean, somewhere in that region. And it's actually quite well in between here. The location itself, it's not that critical. It will be here. And now I will write here out. Okay. That's the output side. We come later to how I put that into action. And now the input side then. Of course, if the input holes are too late, closing too late, it means that it's already starting to compress the air, and the hole to input side is still open. Not a very good thing. I would like it to close. Actually, the compression is smallest at that point, and now no. Not at that point, it's at that point. Yeah, really. And now I would like the holes again to close before it starts to compress the air. Not so that we don't lose compression there. So the input holes should be. And now, furthermore, there is a thing that these should be, how would I say it? It would be beneficial if they would be already open right when the compression cycle is ended and up to the point where it starts to compress. So, well, it's not easy to accomplish that, so we have to get some have a compromise here. It starts around here and ends up here, the region. maybe around in that area, so that the holes should be closed latest to at this point. I mean closed. So if there are holes, so the hole should be like that. Same thing, by the way, in the output side, the holes should be like that. Not like I don't want to draw it. So not in the middle of that line. They should be closed before that line is bypassed. So same thing here. So the holes should be something like this. And my intention here is to make the holes, several holes, staggered like this. On both sides actually. Like that. And then there will be a screw here and a screw there to push it into the, well, something like this. Okay, so, and this is in. Okay, well, that's how I'm going to put this thing together. So let's see now if I can pull this out from there. Yes, I could. All the vanes are now in there. There is still one on the rotor itself. Not just one, but two. Okay. Okay. Now it's completely vane free. And now this should also be dismantled. Okay. So, well, let me dismantle this one, and then the next step is to attach this to the milling table. Yeah. Okay. Well, a lot of hardware here just to attach one thing on the table. Okay, and I'm using the grooves of this table to align it. But I will have this is copper foil, it's 0.1 millimeters wide. I put it under there. So I won't harm my workpiece. It also accommodates some of the irregularities of this groove. And now I will be using these machinist vices here to support it from the sides. I placed them in advance here now because, well, because. And then we need a T-nut here somewhere. Oh! Perkele. Of course it went all the way in. That was not intentional. Okay. It's about there. Yeah, okay. Now let's do this one more time. Little bit less, with little bit less speed. Then I have this. This is aluminium. I put it inside there, like that. Okay. And then the normal setup with all these components here, like this, I think. Yeah. And then that one there. And then one washer and a nut. And now I have to wiggle it somewhat so that it at this point this shouldn't be tightened too tight, just like a little bit more than finger tight. Okay, it's there. Then I will do the other side as well. Now I can, because I can tighten these a little bit more. Actually, I will tighten them fully at the moment. Yeah, there you are. Now, if I would mill it right away, the surface it's lying on the table is it's only about 10 millimeters there. That's too little. It would vibrate. That's for sure. So therefore, I have these machinist vices. I just tighten this side first. I'm pushing it this way so that it's flat on the sides of this thing. And then I tighten this. So now it is supporting the workpiece against the table, and now we have a wide area here, a lot wider. And I'll do the same for this one. Now it stays there and doesn't vibrate. Okay, that's how I attach a cylinder on milling table. Usually I do it like this. Okay, well, I had to reorient this, and the reason are these tapped holes. Next step is to create a flat here, which is 30 millimeters wide, and it starts, it leaves about 4 or 5 millimeters on the ends for the sealing surfaces. I don't want to extend the flat to the ends of this workpiece. Just, only about, even 1 millimeter would be enough, but let's be generous here and give it 4 millimeters. So, like that. Now the edge of this is 4 millimeters away from this surface. Well, how I aligned it, I used this precision tool, put it against this side, and then rotate this by hand until it scrapped this one a little bit. So, the tolerance here is not that critical at all. So, next step, I will start milling it, and I will do it so that I will do one groove here with this one until I reach this wide, and then I do the rest with that depth. It's amazingly little you have to mill off from that surface, but it's still too much to be right over those holes, so therefore they must be located like that, so that I don't poke into that hole. I don't want to do that. So we start from here. The X direction is locked. I will feed it manually into Y direction, and this is it now. Well, that surface finish is, well, it's not entirely bad, but it's not good either. I need to fix this. So this is just an ordinary boring bar, nothing more. But you can use it as a fly cutter. Yeah. I need to, well, sweep the surface. I will peel off only about 0.1 millimeters from here. And after that the surface finish should be way better than it is now. Okay? Well, apparently I didn't push the record button of my camera. So, well, that's usually what you need to do in order to get some video footage. Well, anyway, this surface is now, it looks like strange, but it's really flat, and the surface is good enough for a sealing compound. The previous had such scratches that were not compatible with those. So, yeah, this is a trick I have learned to do with these things. So, yeah. So, the hardest part here when I did this was to get it down to the corners here, so that I don't crash my tool into there. But that everything went just fine. And this has to be on low gear in order for me to be able to extract the... Oh man. Yeah. Oh yeah, there you are. So, well, misusing your boring bar. Well, and my microphone is going all around the place. So, misusing a boring bar. So now, next step will be a lot of holes into that one. And I need to see where to put those and so on. So, let me do some thinking here. Well, here is my drilling plan. Well, the intention here is to drill and tap 3 holes, one here, and one here, which are 15 millimeters from this end, 50 and 85 millimeters from this end. Well, the placement, the absolute placement of those holes is not very critical, but the relative placement is, and I can get them down to quite good accuracy. So this drill is now located about plus minus 0.1 millimeter from this end to here. Okay. Furthermore, the width of this flat is 29 millimeters. I didn't dare to make it any deeper because we have, well, the bolt holes here. So, well, first those 3, and then we have a series of air holes, which are these other holes here. As you can see, they are staggered. And the reason for this is to get the surface down there sort of even, so you don't have a wide open gap there, but you have some meat between the holes. And these are going to be, these are now 3.3 millimeter holes. They are tapped to M4. And then these holes, 5 millimeters maybe. Okay, that was a lot of drilling. Now I will clean up this mess and reorient this piece for the input side holes. These are the output side. So, well, here we are. Now I'm going to do the same thing to, this is going to be the intake side. And well, it's a very similar process. I will first make a flat, and after that I will drill quite a lot of holes. Actually, because this is the intake side, I need to make more holes to this one. But the holes are of the same size, there are just more of them. And furthermore, since there is no pressure in this side, I can attach the piece with only 2 screws. So, yeah, so let's just do it. Oh yeah, and now as you can see, I'm not using the high-speed steel thing, I'm using carbide. Well, I hope that the surface finish becomes adequate at the first try, so I don't need to do any special things with this one. Yeah, and since this is not the pressure side, I can actually deal with less fine surface finish. Well, we have a few holes in here. Quite a few, actually. Well, this hole and that hole there will be tapped to M4. They are going to keep the cover on top of this. The rest, well, yeah. So, I would say it's actually quite beautiful. Not too bad. But this needs to be de-burred. Also the inside, which is a little bit difficult, but luckily I have just the correct tool for that one. So we shall meet at my de-burring station. Well, here it is now. It needs de-burr, really. So first I will take this side, like these holes here. Just a piece like that, and there you go. It's very simple thing to do. And then also these smaller holes, I give them a little bit more chamfer because there will be a M4 thread in them. Okay, done that part. This is actually, does it say it here? Yes, DIN 9 taper reamer. And well, this proved to be really, as you can see, there are some. Now when I just put it there and do like this, keep it flat to the side of the cylinder, it will actually get rid of the burr. This is very sharp reamer, so I just need to keep it flat. Yeah, there is your burr. Well, now just tapping those to M4. Well, this will also create a little bit of a burr in the backside, so I need to take care of that also. So this should go with no trouble at all. Yeah, it does. Hopefully it doesn't break. That would be really horrendous. Well, it's a little bit tight, feels tight, but no. There you are. Oh. This was definitely a flimsy setup, but it did the job. And there you are. Well, this is a tip for you. When you are extracting these like this, I usually keep it like here and here, them both together. And then when I knock here, this doesn't go through because my hands are keeping it there. So now I can, that was actually not tight, but well, it works. Yeah. Okay, I have now, of course I wouldn't leave you without doing this. Now this is attached to my drill press in order to be able to rotate it. And why is it? Well, I wanted to know what kind of sound does it make. Yeah, okay, let's start with low speed and hear how it sounds. Well, nothing yet. Okay. I think the vane's engaged now. A little bit more. Yeah. Okay. That was actually nowhere near the speed it will be rotating when in use, but it's about 300 RPM, and now I need to have a good grip on it, so let's see now. Okay. Well, let's see now. Well, this is supposed to be silent. Yeah, of course, when I put the intake manifold here, it will become silent. But this is, if it would be like that, it would be really bad. And yeah, the sound becomes louder because now the vanes engage all the way. And in addition to that, the oil pressure, when it's created there, at the moment there is just oil to prevent it from galling. So yeah, it's very oily. And yeah, well, at least it rotates quite freely. You can hold it by hand, and there is no strange sounds in it. Yep, there are no strange sounds. It behaves exactly as I assumed it to behave. So, well, in the next episode of Finno-Greek machining, well, I think we are going to make the manifolds for this one. The input, intake and output manifolds. And well, yeah. And then we could also start measuring the pressure it makes. I think it makes some. Well, at least it's very loud. Oh man, this is horrific. Okay, anyway, till then, bye!